I finally found the time to record this video. Actually, it took me way longer than I expected because, first of all, installing ROS on Windows machine is not as straightforward as on Linux, and I did ROS installation, ROS 1 and ROS 2 on Raspberry Pi, Jetsons, and just Ubuntu's many times. It was easy. It was seamless, just sudo apt install, pretty easy. When we're working on Windows, it's way harder, but I had to do it because I will be working on Windows machines. And then in IsaacSim, it also took me a while to just recall from time how to work there, and then figure out which parameters needs to be tweaked to be represented in URDF, because it's not as straightforward as you can see that you have to create local coordinate systems, which are called X forms in IsaacSim. Then you have to create shapes, and you may start making transformations inside those shapes, but that's not going to be correctly reflected in the URDF. So let's go through this process, and I'll add some comments, and there will be also text on the screen so we can go through this process. It is a very simple robot. I'm just copying the second lesson from Articulate Robotics on how to create this super simple robot. So the first hiccup is that when you run the Articulate 1 repo for ROS that was designed for Linux, you have a problem. It doesn't launch the launch file. It stems from the issue that Zacro is not read by Windows because it doesn't have in path. So in this case, one of the solutions ChatGPT gave to me is just change a little bit of the launch file, and you can see the code being changed here. And after that, it launches the launch file with no problem. And you just rebuild it, and you see that it does, but then there is a problem with caster wheel radio. So I forgot this. There's just a typo which I need to remove from there. It still has some errors, but we can visualize that it runs. And yeah, you can see that there's something in there, not exactly what we want, so we just need to remove other typos in there. And here we go. So that's kind of the robot that we would like to see in the end of IsaacSim creation. And yeah, a little bit of changes. Yes, so this is how we want to see it. So now let's open the IsaacSim. It's better to run with a template of default stage because it's just bright. Let's turn off collision visibility for now. We're going to turn it on in the end. We're going to work with collisions, but for now it's easy just to turn it off. And the first thing that we would need to do is to create the X form. It's like a coordinate system and call it base link. It's basically what we're going to have there, and transform it by minus 0.1 meter. And you will see it on the screen that it shifts with respect to the world coordinate system. Let's call it chassis. Let's create another X form and call it chassis. And also we need to transform it a little bit. And we can also add a cube form there with the sizes that we need 0.3, 0.3, 0.15 meters. And we need to shift the X form, not the shape itself. And keep in mind that it's under the base link coordinate system, so it's not 0.15, it's 0.15 minus 0.1. That's how much we need to transform it inside that X form. And we also can add the pivot to our transform, which would just visualize where the origin of our coordinate system in the cube is. It's not going to help anything with the URDF, but it's just easier to see it. And now we just need to choose where to save it. We have to remember that path. And for us to enable the extension for conversion, we go to Windows extension, type URDF, and you will see that one. Just make sure that that radio button is turned on, and we just pull it from the tools bar. In USD path, we need to type the path of the USD that we created. Just right click and copy the URL. And for the output, just choose the folder. I chose the same one. It will create the URDF file in there. Then we need to choose the base link as our root prim path and paste its path. We just do right click and copy the path, prim path, and just paste it in there. Then just click export, and we will see that it just created a file. We can open an Explorer, and you can see the file, URDF file in there. That's a recognizable one that we've seen previously. It has a little bit wrong coordinates, but that's going to be changed. So now click on the base link and the cube and create the physics and fixed joint. And in there, call it chassis joint. And there we need to change transformations in there to what we had in our URDF, minus 0.1, 0, and then for the second object, minus 0.15 and minus 0.075. Because those coordinate systems, they face each other. They don't align. And we can see those coordinate systems over there. So now we just click export, and we will see that prim and that in our URDF, that joint. So we see exactly what we had in our original file with all the coordinates and offsets. So just copy and paste it to a core Zacro file. You can just paste it, and then let's rerun this launch file, and we will see in RVIZ that we have a cube and the base link in there like in original video. Here we go. It doesn't have colors because unfortunately URDF exporter still doesn't do that. Maybe we can do it. So for left wheel, we just follow the same workflow. One thing to keep in mind is that here instead of radius you need to type the diameter, and it needs to be in X and Y. Then also create the reveille joint, choose first the base link, then the left wheel, and then joint, and also export it. And you will see that it creates that joint in there. Also just copy, paste, and rerun the launch file in RVIZ. You're going to see it. Also, we need to start the joint state publisher, so then we can see it. For the right wheel, just copy the whole X form and rename it. Don't forget to change the transforms. Also, don't forget to change the target prim because it still targets the previous left wheel. It's also better to use X forms, not the geometrics prims. It just makes the naming easier. And we can see our two wheels in there. So the next stage is adding the caster. There we just add a sphere with diameter of 0.1. And there is a bug in your URDF exporter, which we will see right now, that it's when you copy paste, rerun it, it creates a 0.5 meters sphere. Just manually change it to 50 centimeters, and that's what you're gonna have. Then to add colliders, just choose all the prims and add a rigid body preset with collider presets. And if you turn on back the collision visibility, you will see that everything in green edges, that means that those are colliders. You see those in the URDF file. Just copy paste and rerun it in RVIZ. You will see that it's going to have colliders. Now we have colliders, which is just the same as your visual enabled. So to add colors, just copy the code from the previous Zacro file, paste it, and there's no problems. It adds it. Maybe in my future work, I can probably modify that extension so it can copy the colors. But we'll see. Maybe it's not needed because usually when you copy the meshes, it carry-ons a little bit of that information. So in such a way, you can use IsaacSim to design your primitive robots. Probably further, I will be working with more complicated shapes, like we're probably going to do on-shape CAD designing, then importing it to IsaacSim, and then creating URDFs with that. But you can see that it's way easier to visualize what you're doing using IsaacSim than just creating Zacro or URDF files just in your text editor. Write your comments, what you think about it, and I would like to hear if you can add something additional to it or some tips that you think are very useful.